Hello, hello. This is Postgres FM. My name is Nik, Postgres AI, and as usual with me is Michael, PG Mustard. Hello, Michael.
Hello, Nick.
How are you? What's new?
I'm good. Not as much new as you, I think. Wrote a blog post recently, been working on
I saw.
cool. Little improvements here and there. Doing some research in the background as to what people want and need. But yeah, you've got some much more exciting news, I think.
It's small, but maybe good. I don't know. I'm experimenting a lot lately with AIs as well, like constantly learning. It's crazy times. People reconsider workflows, obviously, right? How we work. So it's easier right now to ship some stuff. And all the ideas you had during a long time, it's quite easy right now to implement. If you just shift from coding to engineering and organize design and verification of all the details, like benchmarks, and you focus on like architecture more and so on, it's great time to have like helpers. And honestly, Opus 4.6 is quite good, even better than 4.5. So yeah. And others also good. I use them for reviews, other models, including Gemini and GPT, of course. Yeah. Anyway, I wanted to discuss this small toy tool I just created over weekend. And today I'm releasing version 1.2 and publishing it finally. I have good feedback from a couple of folks, not only from my team, but also external ones. And it's working on our production already. And yeah, and I think it gives me the same feeling as I had when I proposed a transaction timeout to Andrei to implement during our Postgres live hacking sessions on YouTube. Because the feeling is, why doesn't this thing exist yet?
Yeah, do you want to say what it is?
Yeah, PG Ash, active session history. I believe with all the new setups and growing existing setups of Postgres, millions of database clusters, I believe wait event analysis has huge potential and heavily underappreciated. And performance sites and RDS is great. Other tools like PG wait sampling, all tools are great. But there is huge potential for various tools and people to understand what it is. And I think a lot of non-experts don't understand what it is, and they are going to explore it soon, I hope, because it's a great tool to troubleshoot database issues. You know, like Brandon Gregg books and his presentations, he says if somebody asks him which Linux performance observability, like Linux performance analysis tool in console, he says it would be IOStat. Because IOStat shows database metrics, disk metrics, right?
Yeah.
Latency, throughput, queue size. And also it shows a little bit about CPU as well. If you have one tool, quickly understand like as much as possible. This is it. Of course, he also mentioned SAR is great and so on. But it's the same thing here. If you choose just one approach or tool which will give you as much understanding of problems and like during troubleshooting, like why database is slow, this is going to be a wait event analysis or active session history analysis. We had a separate episode about it, maybe a couple of them. And I think inside me, there's a huge feeling it's hugely underappreciated. When I talk to people who are not Postgres experts, if they are on RDS, this is default tool for them. But outside of RDS, they don't know what it is. And then even with RDS, Performance Insights, or Cloud SQL Database Insights, or how it's called, Query Insights, it's still like a huge lack of use of it all the time. And I think it should be central in all troubleshooting. This should be starting point. So
Why? Okay, go on.
Yes, so I've been a big fan of PG wait sampling for many years. PG wait sampling is an extension which provides you very precise sampling, 10 milliseconds internally, but you need additional tool like monitoring to export that data for analysis. It's hard to analyze it inside because like you still need like some persistent storage because history it's not like covering a lot. It's just some tail and you need to export it. But it gives you 10 millisecond sampling. It's very precise tool. The problem with PG with sampling, and we had it for long in our monitoring stack, but slowly we moved the attention from it away, and we implemented, we call it lazy sampling, where every 15 seconds our monitoring tool collects it. Because availability, a lot of customers, they don't have PG with sampling. It's present only in Cloud SQL. I wish it was installed everywhere, but no, unfortunately, the reality, so we shifted to lazy sampling, and then something like it's working, it's enough if database is huge. 15 seconds sampling already good enough, and we cannot do 1 second sampling because it's too much, too big frequency, observer effect, it's too much. And because we are external, we're pulling this data to some external tool, connecting to instance on Supabase or RDS anywhere. There is a feeling that this approach is not lazy, infrequent. It's not okay. We need something internally to sample, and then we need to offload. This was number one reason why I thought we need something else. Number two reason, there are more and more cases when databases are small, and it's hard to justify having full-fledged monitoring for them. Because you need to pay basically at least $100 for this monitoring setup. But if your database is tiny and you pay $50, it's like some pet project. There's no way you will decide to spend a few $100 per month for this pet project. But you still need this, because if something happened a couple of hours ago, you need to troubleshoot, investigate. And Postgres internally has everything, right? But it's just, it doesn't have memory. So wait events, there are two columns, wait event type, wait event, in PGSet activity. But nobody is sampling them without, by default. And it was also the third reason. Understanding that current monitoring tools are going to be changed to be better, to provide information in better form for LLMs during troubleshooting. This was reason number 3. That's how I came to the idea, okay, let's implement something. And this something must be low footprint in terms of storage and observer effect. It must work everywhere. And it must be LLM friendly in terms of how information is provided. Not a lot of JSONs, or you need a lot of, you need to write PromQL all the time. But some compact form, you can feed it to your AI agent or something and ask to explain what's happening here and where to dig further. And this is how PGH was created. Because of the first requirement, I couldn't create it as extension. Couldn't create. So I called it anti-extension. And remember, we discussed PG Index Pilot, which is automation for recreation of indexes. It was also created in the same fashion. And also, some sneak peek, we talk with some Supabase folks, and they seem to understand that as well. And there is also a new project called PG Flight Recorder. I hope we will discuss it maybe separately, which actually is very similar to MyPGH, but it covers more. So we are thinking how to maybe unite our efforts. It's ongoing discussion. But it samples PG-stat statements, PG-stat.io, and so on, all the stuff, SLRU and so on. Oh,
interesting.
So there was an old project called PG Profile. Andrei Zubkov created it, and for quite some time it exists. It's great. It's AWR from Oracle, but for Postgres, right? It records all statistics also inside, but it's extension. So since it's extension, it's not available on most managed Postgres platforms. That's why I like the idea of anti-extension, because it's just pure SQL and PGSQL, that's it.
So installation is just a case of running an SQL script that you've got, creates a schema, some functions.
Exactly, yeah. So I think this...
Which you could bundle as an extension, right? But the problem then becomes...
Let me to be transparent. Why not? Yesterday we discussed it, and there is an idea that, yes, it can be extension, non-extension, it's just a bunch of... There is an idea, okay, could be... I honestly have some thought that maybe Postgres could have some concept of packages or something.
There was
trusted language.
Yes, exactly.
Yes, Rust is... Exactly. So David Ventimiglia I hope I pronounced last name right. I apologize, David, if I did it wrong. From Supabase said, and who is developing PG Flight Recorder,
makes sense,
said, yes, so he said this is the direction he's thinking, to package as a TLE extension, right? Because extensions, if it's available, I think it's available on Supabase, on RDS, right? It's like straightforward concept, right? But in some cases, we need to think about all platforms. And in this case, we want to be maximum flexibility. So I'm thinking now to package it in future versions, to package it in both ways, like pure SQL installation or TLE installation. Why not?
Yeah, absolutely. It's just a bit sad that extensions were, the idea of having an extension framework was to make distribution easier. And now we've gone full circle and it makes it harder because everyone's on managed service providers that pick which extensions are available. Exactly. So yeah, it's just a bit of a shame.
This sentiment you just shared, like it's so deep in me. I remember 2005, 6, 7 when like Postgres is extensible. Then extensions concept was created by Dmitry Fountain, right?
Oh, really?
Yeah. He create extension is his thing. Maybe I'm not mistaken, I hope. I can hallucinate often. This happens because I'm overloaded with information. And then everyone was excited. Postgres is so extensible. But we should blame managed Postgres platforms, starting with Heroku and RDS and all others. Why extensions became an extensible concept? Because it's in their hands to decide which extension to add. And they have their own reasons, obviously. Every time they add some extension, it means they need to support it and to have some responsibility if it's secure and so on. I understand that. But extensions became unextendable. Yeah. And every time I thought, I want to implement this in Postgres, every time I decided, no way I will decide to make this extension. Of course, the concept of trusted language extensions is great, but still it's not adopted everywhere. It's limited, right?
Yeah. So this is not an extension, but could be, but it's not to start with, and it installs a couple of tables, some functions. What does it do exactly?
Yeah, let's talk about this, what exactly it does. The idea is let's just collect wait event samples from persistent activity with query IDs and have some history. It's quite simple. I didn't want... So the problem is we need some help to invoke function which will sample, right? And I don't want any Lambda functions or anything. I want everything in Postgres, but I cannot build a background worker or anything because I don't want to create extension. pgcron was chosen as a dependency, and pgcron is present everywhere. And I remember I was driving at that time. I was brainstorming with ChatGPT. Unfortunately, Claude, the voice abilities are not as good as ChatGPT. So I was brainstorming, and we agreed both that pgcron is going to be a problem because it has, as any cron, it has only 1 minute precision. I was driving, I reached my destination, I was starting to doubt. I always doubt when working with AI and humans, actually. Yeah. It's not only about AI, humans also can make mistakes. So I was in doubt, and I said, let's verify, check documentation, check with me. And thankfully, starting pgcron 1.5 per second precision is available.
Okay.
And this was moment, I'm going to build this because I need per second precision. So
is 1 second the minimum though?
It's minimum, yeah.
But I was going to ask why. I was going to ask why 1 second as the default, and now it makes sense.
Yes. Then I was thinking, we are going to write a lot. We need to write query ID and the wait event, and so how to optimize storage? And there are two big problems. First, how much we are going to spend in terms of bytes, and if we're just writing. And second, we know Postgres MVCC and bloat issues, right? So if you implement some ring buffer for your storage, anyway, let's jump to solution. I knew the proper solution from Skype, PGQ, SkyTools PGQ, 3 partitions and rotation, right? So I just created partition yesterday, today, and tomorrow, logically. So yesterday is read-only partition fully filled, 24 times 60 times 60, right? Records. Actually, no. We need to think how do we store 1 row per wait event pair, or we somehow store it differently. Let's return to this point. Now we have current partition today, and tomorrow is truncated, because truncated is super efficient, as we all know, right? No deletes, no updates, inserts and truncate, that's it. So this is how we implement, and we have visibility right now in current version. We have visibility only for yesterday and today, and you can export it to your monitoring tool. This is we are going to implement compatibility with this extension, not anti-extension, in our monitoring stack. But also there is a plan. Maybe when you listen to this podcast, I already implemented this. There is a plan to have roll-up storage for longer term. I plan to have 1 year with precision, maybe 1 hour or 1 minute. It depends. It's not a lot. So this is how we solved MVCC. Just borrowed an idea from old good Skype from 20 years ago. I still think it's a great idea. So no bloat.
Yeah, so that solves
Zero
the bloat issue. Yeah, exactly. Okay.
Fully. And second, how to find optimized storage. We had several ideas, so we decided, I actually decided, but I agreed that with a lot of benchmarks, many iterations, we chose the idea to store 1 row per second. So it's timestamp, it's database ID, because, not 1 row. If you have multiple logical databases, then it will be as many databases as are currently active in terms of workload at this very second. So at this very
1 row per database per second.
But only those which have active sessions right now.
Okay, yeah.
Yeah, I thought about it. If we have 1,000 databases, it's insane. But it's unlikely all of them have right now active sessions, because it might be if you have huge machine and a lot of things happening. But still, if you have huge machine, you can afford maybe 1,000 rows per second. Maybe no, it depends. There is room for improvement here. But anyway, right now it's 1 row per second if it's only one database active right now. And then we encode everything. But how? We thought about JSON-B, first thing, JSON or JSON-B. Yeah, I proposed correlated arrays and proved me that it's better than, in this case, than JSON-B. 2 arrays, so 2 rows. And then I proposed this encoded 1 array. And benchmarks proved it's better. So we encode wait event, number of sessions, wait event, for example, IO, or for example, lightweight log manager, our favorite, right? And then there is number, how many active sessions were present, for example, 5, and then 5 query IDs, right? So 7 numbers, and then next wait event, and so on. So we have a bunch of numbers. And I didn't want to use 8-byte integers. I wanted to use 2-byte integers, because it should be enough. So we created 2 dictionaries, one to encode all wait events. Okay, actually, every time if you write LW log manager, it's a lot of bytes. Why? We can encode it, and to support, as in recent couple of major versions, there is a PG wait events dictionary, right, in Postgres, which is just a static list of them. But I wanted to support older versions. This thing supports Postgres 14+, so that's why we created our dictionary, to propagate it to back. Yeah.
One thing I didn't understand is you mentioned not using 8-byte integers. Does that include, because query IDs by default are 8-byte, right?
Yeah, so query ID is 8, and that's why we have 2 dictionaries. One to encode wait events, and second is to encode query IDs, to map to 2-byte integers. That's it.
Wow.
And we also, I don't remember, but we somehow solved the problem that it can grow without limits. We solved this, so it cannot grow without limits. We keep it short. I know how we solved it. I remember, because I proposed this solution. By the way, I forgot to say, I created it using 3 AI plus me, so a team of 4 worked. 1 AI was engineer, and 1 was focusing on benchmarks, another was focusing only just on quality and documentation and reviews. And benchmark engineer also focused on reviews, but with specific goal like storage efficiency and performance and so on, low observer effect and so on. And we worked many iterations like crazy, and I did it the whole thing is coded in Telegram, so I didn't touch anything. Yeah.
But you reviewed it, right?
I reviewed what? Like, I didn't review code. What?
Really?
Really? I reviewed only results of benchmarks. I cross-check from two engineers, AI engineers. I cross-check results, like they work. Code, I trust this code actually. It works in my production already. Yeah. Why should I look at this code if I know that it was very thoroughly tested and benchmarked and reviewed many times by AI?
Well, yeah, that's the why for me. But yeah, anyway,
I
it's
understand
interesting
your
how
question.
different. Yeah.
I understand your question, but in this case, I think it's quite solid. I actually checked the code and it follows my style.
Wait, you just said you didn't check the code.
I checked pieces of code just ensure. Before I decided not to look into code, I made sure it's written according to our style guide,
Yeah,
and I
yeah.
like what I see. So style corrected, how we write PLPGSQL. I have my already very well established, because PLPGSQL is the most popular code language for me last 10 years. So I wrote a lot in it myself. So that's why, like, when I made sure it's producing good code, I didn't see the final version of everything. But I know
Yeah.
it was thoroughly tested in many aspects. Yeah.
Yeah.
So back to storage. This is how we encode and how we solve this unbounded growth of query ID dictionary. My idea, actually, I'm excited because you can engineer solutions thinking about like algorithms and data structures, and you don't need to code everything. AI is coding. So I decided to have 3 tables, one per every day. That's it. And the same like rotation. Like we have dictionary for today, we have dictionary for tomorrow. AI said there was a doubt because query ID might not match, but we don't care because if the same query ID receives different encoded ID tomorrow, it doesn't matter because we don't work with this data directly. We work with this with some interface functions which expose it to user, and the user doesn't see the encoded numbers at all.
Yeah, and once you look them up, then it's the same query ID anyway. Okay, yeah, that makes sense. Great.
And it cannot grow unbounded anymore, right?
Yeah.
Yeah. And I guess
Nice.
for a lab approach, we also will need a separate dictionary. That's it. Which might be bigger, but
Wait, why?
Because I want to have history for 1 year at least, or maybe half a
Good.
year.
Okay, fine.
But it will
Yeah.
be already like compacted, and query IDs not all query IDs will go there. Only most important, which like are most popular or participating in spikes.
Yeah. So make sure I've understood. We've got 3 main tables, only 2 of which will contain data at each time. A day's worth of data, like all of yesterday's data
Per second.
and then and then today's data until now. Like it's like
Yeah.
one and a bit days data at any point in time.
Yeah.
But and that's fine because the main point of this is something was slow recently, like we had an incident 10 minutes ago or an hour ago or over the weekend. And in fact, over the weekend's interesting, but there was something fairly recently we want to look into, and normally that's within a couple of days.
Yeah, I think maybe we should allow to configure how many days raw data is stored. Right? Anyway, I know of this approach with 3, it's from PGQ, as I said. This is 3 partitions in rotation. You cannot see a day before yesterday with it until we implement rollup approach for like longer term storage. And I forgot to mention that how much of data it is. So per one row, if it's 5 backends active, it's roughly 100 bytes only. I forgot to mention also that I decided, with knowing alignment padding, I decided to also encode timestamps. So it's 4 bytes instead of 8, right? 4 bytes Unix timestamp, but it's shifted. It starts with January 1st this year. So it will be enough until the end of century almost. And the database ID, it's 4 bytes. It was already, it's all ID, so 4 bytes. 8 bytes plus this encoded data, roughly 100 bytes if you have 5 active sessions. And for example, if you have a more loaded machine, it will be, for example, 50 average sessions on average, it will be producing 30 to 50 megabytes per day only, which is acceptable for us, like absolutely. I also forgot to mention that you cannot use it on replicas. This is downside. We forgot to mention the README, but I thought about it before we implemented it. So it's obvious because we need to write. But it's fine because we observe more and more even bigger clusters coming to our consulting which don't have replicas. And they run...
Or only HA replicas.
Yeah, this is a good point. Actually, yes, they recognize HA is needed, but they are okay to live with one. Somehow, quite long, they live with it. Like, it's so unusual. I still think classic 3-node setup is much better. But reality is just showing different thing, because cloud resources, as we discussed multiple times, they are so reliable already that people are okay. And also Postgres is performance. You don't need read replicas for quite some time because they add complexity. So that's why I thought, okay, this is only for primary. It's enough. And I'm satisfied with results, like 50 megabytes per day for a loaded cluster. It's great. I'm thinking maybe we'll be like, let's keep 7 days of raw data or 14 days of raw data maybe.
Yeah, I could easily see at least the weekend thing makes sense to me, right? You come in on a Monday and it turns out there was some blip on Saturday. It would be a shame if that data's gone.
I agree.
Yeah.
I agree. Yeah. So and we have a bunch of functions which allow you to see what's happening. Give me like overview of last few hours, for example, or previous day. Which top wait events happened and which query IDs are participating there.
Yeah.
And it joins with PGSA statements if it's available to present some high-level settings, macro-level settings for each query ID which is participating in some wait events. We also implemented visualization with bars. It can be monochrome visualization or even colorful for PSQL if you do some trick. And I enjoy it. You see basically performance insights right inside PSQL. It's quite fun. And you can, for example, overview last 24 hours when you think you can zoom to specific area. You can understand which queries. And of course, it requires some typing work. But since how it's organized, quite straightforward, you can let your LLM to do it, right? If you connect using some read-only user role, and let it troubleshoot, it can quickly find which bottlenecks. Is it like IO-bound workload? You need to increase disks or give more memory. Or it's like there is a heavyweight log contention. Which queries participate? It's quite good in terms of this kind of troubleshooting.
Yeah, definitely macro level stuff. But I saw there was even some micro level abilities as well, like looking at specific queries weights by the query ID. That's cool.
You can ask, for example, for a specific query ID, you can say which wait events. It mimics a little bit what we have in full-fledged monitoring because we have all this. And here is just like in textual form, you can do this kind of things. For this query ID, what are wait events during last hour or previous day? And for this wait event type or specific wait event, what are like top 5 query IDs and their macro level characteristics? Yeah, it's still macro level actually, because you still a lot of aggregation is happening here. But you can jump to micro level, specific query ID and see plans and start working with this. So there is a bridge here, right? Yeah, there is a bridge. So anyway, it's early days. I'm releasing this week. Let's see how it works. Is it useful or no? I wanted to add that this thing feels to me as, one more thing. So this is poor man's monitoring, self-monitoring, right?
I think it's not. I don't think so, but yeah, sure.
It's quite straightforward. This trick with pgcron. I forgot to mention, by the way, that if we sample every second, pgcron by default writes logs to a table.
Oh yeah.
So I think pgcron can be improved here. For example, I would turn it off for this specific job. I don't need logging here. I just need to see errors, and I don't need errors to be stored with full ECID. Postgres log itself would be enough for me to troubleshoot what's happening. Anyway, there's a potential for pgcron here to be slightly improved for these high frequency jobs. But what I wanted to say, this is like self-contained, self-monitored system, right? So you can, even without LLM, you can write some analysis inside Postgres, so it could produce some reports and analyze what's happening. Maybe it's time to add more, increase shared buffers, for example, because we see a lot of IO data file read or something, right? Or maybe we see a lot of time spent on heavyweight logs, so we need to signal that workload must be redesigned to avoid contention on heavyweight logs, right? But there is a trade-off. Should we monitor inside or outside? And I think there are pros and cons. We discussed it, right, already? Right?
We did.
Yeah, that's...
I had one last question, though. I think, by the way, the reason I disagree is I think it's actually just another tool, right? It's another tool in the tool belt. If you self-manage or use a provider that doesn't have weight sampling, this is a valuable tool in its own right, like regardless of monitoring, especially when you mentioned the overhead from monitoring externally, you'd only get, let's say, 15-second frequency or something of that order of magnitude. To get 1 second frequency is an upgrade, not like a poor man's solution.
Yeah. It's not 10 milliseconds.
It's no true. Good point. So the last thing I wanted to ask, because you always ask our guests this, on the license front, you've chosen a really permissive license, Apache 2.0. Why?
Why not? It can be embeddable to some stuff. And I even think, honestly, to be transparent here, I think it will contribute to my business, because if we have this everywhere, it's easier for us to explain which problems and what should be done about it and improve health and support people like they work with Postgres. So we right now not in quite good position, because Cloud SQL, this is one of not many but quite great things they have, is that they have PG-wide sampling, super great. But RDS, they have their own proprietary tool, Performance Insights, which is great if you only on AWS. But if you think about interoperability, or how to say, like you want to be able to work with any Postgres, Performance Insights, Database Insights, they call it right now. It's some proprietary API and it's not transparent. And also external dependency, I always think, okay, how good is it? Is it trustworthy? Maybe there are also bugs. I don't see code. Right, I cannot know. I don't know. Maybe there are bugs there. RDS quality is great. Let's agree. RDS quality is great, but still, like sometimes you doubt, like how exactly it works. This is fully transparent, works everywhere, right? And that's it.
Yeah, nice. All right.
Yeah.
Thanks so much, Nikolai.
Yeah, thank you. So yeah, everyone is welcome to try and contribute and fork anything.
Yeah, I will. I'll stick it in the show notes, obviously.
Right.
Make it nice and easy.
Thank you. Yeah, good.
All right. Take care. Catch you in a bit.